Well, I hope you can see my screen, right? Is there any problem related to that? I hope you can see my screen properly, the presentation window.
Yes, sir.
Okay, fine. So let us wait for one more minute so that we can allow other students to join as well. And then I'll be starting. Okay, fine. So we have got only 28 participants. Okay, so let us wait for the minute. Okay, uh, just a minute. Okay, I would request everyone that from the very next day, it would be better if you join the class at least 2-3 minutes prior to the schedule, so that I will not have to switch in between the windows. That is very boring. So, while I will start the presentation, if somebody is requesting to join the class, then I would have to switch in between the windows, which is really difficult for me. So, I would request everyone to join the class at least 1-2 minutes before the schedule. Okay, so I'll be sharing the link at least before 30 minutes, the schedule, 30 minutes of the schedule. And okay, so we have got 30. Okay, Christian, you do not need to say present, sir. I do have a Google Meet attendance, so automatically it will be capturing the attendance. So you do not need to mark yourself as present. Okay, so let us start with the presentation. How many of us are present? Yes, we have got 40 students. Fine, fine enough. So I hope you all had a nice introduction to software engineering. SD ma'am has already given you an intro to software engineering, what exactly the syllabus is going to be. Perhaps you have already have an idea about what the curriculum is, and what are the portions SD ma'am will be covering, and what are the portions that I'm going to cover for rest of the semester. I'm going to basically cover the process modeling, intro to software engineering, cost benefit analysis, mathematical problem related to cost optimization, cost calculation, along with a unified modeling language, the entire unified modeling language that you have to practice at your lab. Okay, so the softwares that you'll be using, I don't know whether you had a lab already or not, but in your lab basically you guys will be concentrating on creating software design, and you'll also be dealing with some project management issues. So that UML design as a topic that deals with software design, I'll be dealing with that entire UML part. And apart from that, the software quality assurance, quality management, this entire part will be covered by me. Basically, I'll be covering the mathematical portions related to software engineering, that is cost optimization, cost calculation, software process modeling, introduction to software engineering, software design, basically, which consists of the UML modeling part, which is very important for you to know, as because when you'll be joining industry, the first thing that you would have to understand is how UML works. Because basically, as a coder, you'd have to go through some UML design to understand the project constraints, and then based on that, based on those graphical representations, you'll be writing codes. You'll be writing some effective codes. So, and obviously I'll be talking related to software project management and software quality assurance. Quality assurance do deal with some mathematical models, so I'll be talking related to the mathematical models in due course. So as you already have a nice introduction, I hope so, let me not take much time to give you another introduction. So somebody's asking to join. Yes, Omar to Banerjee. Okay, fine. And now what I would have to do? Okay, again somebody's asking. Okay, Tushar. Okay, guys, this is really tedious for me. It's to switch in between the windows. I would request everyone to join at least 1 minute before the schedule. Okay, and I would request everyone to turn off your mic. Okay, so let me start with the topics that I'm going to cover. I'm going to talk about some basic issues. Okay, anyone having any problem? Anyone having any problem related to the audio that you have? Please, otherwise, please turn off your mic, please. Okay, so the topics that I'm going to cover today, these are the basic topics that I'll be covering. I do have one another agenda apart from the topics mentioned in here. I do have the basic introduction to software process model. Intentionally, I didn't mention it as because I do not know whether we will have sufficient time to cover this thing or not. So let me start with software and its types. It's a basic thing, as you all know that software is basically the logical parts of any system. So if you have to deal with the hardware that you have, if you everyone please turn off your microphones, please. Otherwise, it is creating a noise. Okay, softwares, as you all know, that the conventional definition. Just a minute. I'm having a noise. Abhishek, please turn off your mic. Abhishek Jha, please turn off your mic. Okay, fine. So as because I was talking about softwares, as you all know that softwares are basically the logical components of any system. So if you want your hardware to work properly, if you want, sorry, I had a call. Okay, so hello, am I audible properly? Is there any issue?
No, sir.
Okay, fine.
Yes,
So
no, sir.
if you just talk about a software, then softwares I can say that it is basically logical component based on which you'll be dealing with the hardware that you have. If you have to give any instruction, or if you want that the hardware that you have will be working according to your instruction, then you should have this logical layer. That's the conventional definition that all first and second year students do say about how a software works, what exactly a software is. But basically, this is the diagram, the picture that I'm showing you. Basically, it is the software from the point of view, from the perspective of a software developer. Basically, whenever you develop a software, you may consider a software to be some programs, some interrelated programs, along with some documentation and some operating modules. This is very important for you to understand that whenever you deliver a software, you obviously can develop a product for your own, but whenever you are developing a product for your customer, for your client, then obviously at the point you are delivering that particular programs, they are to be interrelated. You would have to integrate them. Some interrelated programs have to be integrated to form a system, and along with this, along with whatever you want to deliver as a code, as an executable program, you would have to deliver the documentation too. The documentation will consist of the software licensing documents. Maybe it's a licensing document, maybe operating procedures, maybe the installation guides, maybe some formal documents, maybe invoices. These are the documents that you would have to supply at the time whenever you want to deliver a particular product. So it is not at all it is not just a logical component of a system, rather it's much more. It is a set of logical components. It's an integrated set of logical related components along with some documentation, along with some operating procedures or user manuals. So this is the perspective of a developer. If you ask a developer what do you mean by a software, always they will say a thing like this, that it is a program that I develop along with some documentation. Every code should have a documentation to understand the functionality of it. And apart from that, if you just want to take a deeper look into how many different types of softwares you may have from the point of view of a developer, from the point of view of an organization, development organization, you may say that they may have two different categories. Either they can be of generic type. Okay, let me turn on, just a minute. Let me turn on my annotation tool. Yeah, just a minute. Just a minute. Yes, I do have that. Fine. Yeah. So what I can say is, from the perspective of a developer, from the perspective of an industry person, from a developing organization, if you ask somebody that what are the different types of softwares you may have, they would say two different kinds of softwares maybe out there. One is a generic one, and one is a bespoke or customized software. Generic products, you can say if it's a generic product basically means it's a kind of product that is developed just to grab a common market. And for development of that kind of product, you do not need to ask anyone to clarify the requirements. An example for a generic product can be any product which is available in the market, like an Axe deodorant. So if you want to have a deodorant, you just go and procure it and you use it. Hindustan Unilever has never asked you what exactly your requirements are. Maybe internally they have surveyed the requirement of an audience, requirement of the a mass rather. So for this kind of product, for a generic product, you do not need to ask anybody to clarify the requirements. So you do not need to ask anybody to clarify the requirements. On the other hand, if you want to have a customized software, if you want to develop a customized software, this is basically based on the requirements as clarified by some people, some group of people, or by some organization, or by a single people. So this particular kind of software, on the other hand, is developed basically based on the requirement as specified by the customer. So it's an example, for typical example for the customized softwares can be a banking management system, rather a financial management system, employee management system. They are typically customized tools. So if you want to develop a customized tools like them, then obviously you would have to ask the person or the organization or your customer to clarify some of the requirements based on which you'll be developing the products. First of all, as a developer, as a development organization, or being a project manager, it is very much essential for you to clarify what the requirements are, what the requirements of the clients are. Only then you will be able to grab the requirements, you will be able to analyze the requirements, then only you will be able to create a design, and then only you will be able to code. So whenever I give you a problem statement, usually whenever you have a problem statement, we do usually think that how to code for it. Suppose that if I ask you to develop a product, a very small product, a system, an employee management system, like where you will be having an option to log in and you will be entering your data, and finally you can fetch it from the database. Then first of all, what exactly you will think? So what user interface will be using, what technology will be using, what database will be using, how much convenient it will be for us to communicate in between the database and the user interface. But in industry, the approach is something different. Industry thinks from a different perspective. Industry thinks is, first of all, you would have to grab the requirements in a proper manner. You analyze it. You analyze it to make sure how much feasible that requirement is, whether this requirement is implementable or not. If it is implementable, then you go for analyzing it in a different way. You go for making a schedule, you make a team, you just consider how many phases will be up there, you make a time frame, you make some milestones. Milestone means obviously within what period of time will be completing what amount of project, what percentage of the project should be completed within what period of time. That is a milestone. Basically, it's an industry term. These are the things that has to be considered. Whether you are developing a generic product or a customized product, these basic things have to be considered in industry. So the approach that industry uses in terms of development of a product is a pretty different way. So if we consider this one, this is very important slide, I think, engineering versus production. So why it is software engineering? Why not it is software production? Engineering is basically a terminology that is related to making some blueprints. As I was talking about this, engineering is all about making some blueprints of how to develop the product, making some plans, making a schedule, making a definite costing plan about what the proposed cost of the software is going to be. Not only the software, if you are in a position to engineer something, that you'll be creating a schedule, you'll be creating a deadline, you'll be creating a costing plan, you'll be making some feasibility analysis kind of thing. That means how much feasible that particular product is going to be. Let me give you an example. Suppose that you are about to launch a product for a particular country, where the average annual income of the people is not more than 10,000 rupees. So in that country, if you deliberately consider the cost of the project to be more than rupees 1 lakh, then nobody is going to buy it. That is a kind of feasibility analysis. Or you can say that for a group of people, if you are developing a software where the user interface is basically based on user interfaces, basically, just a minute, somebody's asking to join. Okay, fine. If the software is having a user interface in English, but the target audience, they are not that proficient in English, rather they are proficient in Japanese. So I think it would be better if you develop the user interface in Japanese. That is a kind of feasibility analysis. Okay. So engineering is all about that. Engineering is all about making a blueprint, as I was talking. Engineering is all about making a schedule. Engineering is all about having an inner view, about view in depth, to have a projected view, rather you can say. On the other hand, based on the blueprints as made by you, production lines or production people, they will be considering some of the factors, and they will be manufacturing or they will be developing a product. This is true for all the industries, not only in case of software industries. Rather, what I can say is software industry is having some definite distinction as compared to other industries. So production on the other hand, production lines on the other hand, they will be considering the blueprints as proposed by the engineers, or whatever plan or schedule you have. Considering this one, they will be start developing the particular product. Often products are measured by business outcome parameters, while manufacturing is assessed by the product quality metrics. So whenever you are delivering a particular product, you have to have some quality metric too. That means the quality of a software product or quality of any product has to be maintained properly. So these are the things that you have to consider. I hope I'm clear related to engineering and production. Basically, software engineering is all about related to making a blueprint about how to develop a software. It's not always true that somebody is clarifying the requirements and you'll instantly be starting coding. It's not about writing codes all the time. How much good coder you are, that really doesn't matter unless you have a good blueprint or plan. Your projected path, your projected project schedule should be fair enough with respect to some engineering plans, and obviously based on these plans you would have to proceed. Okay, so I hope you don't have any doubt related to this. Anyone having any doubt, you can let me know. Any doubt, guys? Anyone? Am I audible properly? I don't know. Guys, you can let me know whether I'm audible. I'm not audible.
Yes, sir. No doubt, sir.
Yes, sir, audible.
No problem.
So, do you have any problem? Do you have any problem related to the slides that I've already presented?
No, sir.
Anyone? Okay, fine. Okay, fine. So let us talk about the formal definition of software engineering. Rather, you can have a much more formal definition of software engineering if you Google for it. Okay, there was an IEEE definition, and you can search for the formal definition. This is rather an informal definition, a little bit less formal definition. Okay, somebody's asking to join. Okay, fine. So software engineering is an engineering branch associated with the development of software product using well-defined scientific principles, methods, and procedures, as this definition says. So in between the presentation, if you have any doubt, please do let me know. You can interact with me. You can just definitely let me know what problem you have. Okay, if I'm not audible, if you have got any other problem, you do let me know. So as I was saying, that software engineering is basically terminology related to This is basically a branch associated with the development of software product, as I was saying. So how many different steps you'll be having once you want to develop a particular product, that is basically you would have to consider. Okay, I am having some audio issue, I think. Am I audible properly?
Yes, sir.
Yes, sir.
Okay, fine, thank you. So basically, whenever you will be developing a particular product, then you'll be going through different phases. So basically, it's a layered approach. What are the layers that you'll be considering? That I will let you know. So let us move on to the next slides. These are the slides that are very important for you to understand, and I intentionally included these slides. Although these slides do not have any direct relationship with the curriculum you have. Please do go through it. As per the IBM report, these are the facts, features, and some case studies. I have picked them up by Googling. So as per the IBM report, 31% of the project get cancelled before they are completed. 53% overrun their cost estimate by an average of 189%. And for every 100 projects, there are 94 restarts. It's very important for you to understand that if you do not have a proper plan, then you can have a scenario like this. If you do not deliver the project at time, if you do not have a proper schedule, if you do not have a proper budget, then you may have a project restart. Your project may be thrown away. You may not be considered as a proper organization to develop a particular software, whether it is a customized or a generic product. So these are the facts. These are the facts which came in the survey as made by IBM. This most important thing is there's a law called Moore's law, that the processor speed or memory capacity doubles in every 2 years. That means the speed of the development of hardware is pretty high with respect to the speed of development of software, as you can see in this graph. So in every 2 years, can you imagine, in every 2 years, this processor speed of the memory capacity doubles. So if you want to get yourself tallied with this, if you want to tally with this, then the speed of development, the style of development, the technologies that you are using to develop a product should also be changing rapidly. So Moore's law says that whenever you are developing any particular software, you have to get yourself tallied with the changing version of hardware. Other than that, you will not be able to cope yourself up with the changing needs of the hardware industry. Okay, so this is very important for you to understand. And the next one is a little bit funny. Managers and technical persons, those who work in software industry, they are often asked these queries like, why does it take so long to get the program finished? That means you promise that the product is going to be delivered within the next 6 months, but you failed to reach the deadline. Why it is so? Why the costs are so high? Initially, you told me that the product is going to cost rupees 10 lakhs, but right now you're telling me that 30% cost will be increased. Why it is so? Why cannot we find out the errors before release? That is very much important for you to understand, that whenever the first version of the software is launched, then obviously that comes ready-made with some pre-installed bugs. You cannot expect to deliver a software without having any bug. So whenever the client will say that, why do you have these bugs, then you would have to keep track of why these bugs are up there, what is the reason behind, and you'd have to keep track of the reason behind, and you'd have to remove them accordingly. You would have to release the bugs, you would have to remove the bugs by finding out what is the reason behind. You'll be fixing the bugs rather, and as the time progresses, the total number of bugs that you'll be experiencing should be lesser than that of what which you started in the very beginning. Then the last but not the least, why do you have difficulty in measuring the progress of software development? This is a very valid point. So if you set some milestones means, I hope I'm clear already. Milestones means it is a benchmark that measures how much progress you have made so far. Suppose that your project schedule says that you would have to complete a particular first phase of the 30% of the development should be completed within 6 months. So after that, you will be delivering a prototype. Definitely, you will say your client that it will take around 2 years to complete the entire development process, and your client is not going to sit idle for the next 2 years. So what exactly you would have to do? You'd have to deliver a prototype to the client after first 6-7 months, after 30% or 40% development is over. For that, you would have to have a milestones. Now, if you fail to deliver the milestone in time, then probably you will be asked this one: why do you have difficulty measuring the progress of software? You can say it's 30%, but client may say it's not 30%. It is only 10% of the overall talks that I already cleared out. So the basic thing is you need to have a proper schedule so that you will not be in a position to face a kind of situation like this. Okay, so let us move on. This slide is a very simple one, and just a minute. This slide is a very simple one, and obviously, are we talking more related to what I've written in here? Please turn off your mic. Those who have their mic turned on, please turn it off. Okay, so formal approach and informal approach is whatever approach you use in software industry to develop a product, to make the documentation, to analyze the requirements, to test the product, whatever approach you use, they are to be categorized into either formal approach or informal approach. Formal approach means just like in conventional case, what happens if I give you a sufficient time to write an assignment, then you'll be giving a cover page, you'll be writing the question with a blue pen, you'll be writing the answer with a red pen, or maybe something else. So you'll be doing something in a formal way. But if I give you only 24 hours to do this thing, then what exactly will do? You will search for that answer in Google, you'll be copying it up and you'll be pasting it in WordPad file or Word file, and you will mail it to me. That's an informal approach, just because I've given you a lesser time to complete the assignments. Or rather, if I say that please do write the assignments, and if you submit the assignment, I will give you an iPhone. Then what you will do? You will definitely try to convince me so that I can give you an iPhone. So as because the cost to deliver me that product is high, then you'll be doing something good. But if I say that you submit me the assignment, I'm going to give you a Nokia 1100, then probably you'll be searching for Google and you'll be sending me back by typing this one, by pasting this one in the body of your email. The same thing happens in industry. If I give you sufficient time, if the project cost is huge, if the project schedule is huge, if the time periods that you decided after which the product is going to be delivered is huge, then definitely you'll be following formal approach. Rather, you can say in different word that if the volume of the problem, if the vastness of the problem is pretty high, then you'll be always following a formal approach. On the other side, if the vastness of the problem is low, if it is a very small one, then definitely if the constraints are less, then you'll be following an informal approach. So let me give you an example for this one. So if you have to count the total number of people in CSC fourth year classroom, then what exactly you will do? Probably you will take a roll call register and you count how many students are up there in the CSC fourth year classroom, right? But if I ask you to count the total number of people in India, will you be able to make a roll call? I think you will be able to do that. But you take a note on this. Both the problems, counting total number of people in CSC fourth year classroom and counting total number of people in India, both the problems are pretty simple number counting problem. Approach that you are following to count the total number of people in CSC fourth year is not at all applicable in case you want to calculate the total number of people in India. As because the second problem, the vastness or the volume of the second problem is quite a big. So you would have to have a formal approach in order to count the total number of people in India. That's what I was talking. Depending on the vastness of the problem, definitely you would have to take a decision that whether the problem approach is going to be the approach that you'll be following, either it's going to be formal or informal, right? Okay. So let us move on to the next one. I hope SD ma'am has already talked about this one. Software SDLC is an acronym for software development lifecycle. Basically, whenever you develop any product, it is not always true that whenever somebody is clarifying your requirement, then you'll always be writing codes. You'll be communicating this particular code or the user interface with the database. You'll be making an exe and you'll be delivering. It's not that easy. So you would have to go through several different phases. Being a part of an organization, you would have to go through several different phases to complete the entire development. If you don't believe me, let me tell you one thing very frankly. Whenever you will join in industry, and the first subject that you would have to go through is this one, software engineering. Because unless you have a proper understanding of this particular subject, then you will not be in a position to work as a team member. You should have an idea about the process flow of what exactly is needed to develop a software. So this SDLC is very much important for you to understand. In the modern scenario, SDLC has got so many different variations. I don't know whether you have heard it or not. There is a particular framework in the modern industries up there, which is called an Agile framework, which is the most modern one. Okay, so this Agile framework is the most latest one, depending on which you'll be able to develop your software. There's a framework considering each and everything, like a project scheduling, staffing, development, design, maintenance, delivery, deployment, everything is included in it. Similar to that one, this SDLC concept says that whatever steps are involved, the process of development is basically a layered approach. It's a step-by-step approach. So whatever steps are involved in the process of development are to be grouped together, and the grouping, the combination of all those phases are basically considered as SDLC. So basically it starts with this one, with this particular phase, requirement analysis. So this is the first phase with which you should be starting. Then after requirement analysis, that comes design, then implementation. Implementation means coding, hardcore coding. Then testing to check the functionality, then evaluation to deliver the product and to check whether all the functionalities that the client require, whether they are met or not. Okay. And let me talk about those phases individually so that you can have a deeper look. Okay. So let us move on to the next slide. Okay, intentionally I have included this slide so that you can have a better understanding of SDLC, because in future you would have to deal with each and every phase of SDLC, and your basic syllabus, the syllabus for software engineering, each and every chapter of software engineering is basically related to one phase. So initially you'll be starting with planning. The planning deals with defining the system to be developed. So basically you will be asking your client to clarify what exactly the requirements are. Is that slide visible?
Yes, sir.
Okay, fine. So basically you'll be talking with your client, you'll be asking your client to have an idea about what are the phases to be, what are the exact requirements are, set the project scope, that means in under which scope the project is going to be, whether the project volume is going to be big in future or whether it's a small scale project, and development of a project plan. That means what is the, depending on your experience, you can just say that this project is going to take more than 6 months, or I'll be able to develop the first, I'll be able to deliver the product, at least the first version, first working version within a year. So you'll be making a plan. After you clarify all the requirements, it's time for you to analyze the requirements in the analysis phase. That means a client may clarify you endless number of requirements, but it is your responsibility, being an analyst, it is your responsibility to make sure how many of the requirements are feasible for you to implement. Okay, and you'd have to analyze it. You'd have to jot down the exact requirements depending on which you'll be working in future. You may tell your client, sir, these are not the exact requirements, so I can clarify it once more, and please go through that documentation to make sure whether these are your filtered requirements. This is the basic phase. This is a phase using which you'll be able to filter the requirements. Either you'll be removing some of the requirements as clarified by the clients, or you may be adding some requirements intentionally to make the project simpler. Then finally, you'll be creating some graphical notations. You'll be creating some designs depending on what your coders will be able to code. And finally, you'll be developing. That means you'll be creating the technical architecture. You'll be selecting a framework. You'll be creating the databases. You'll be creating the user interfaces. You'll be correlating them. You will be creating multiple subsystems, and at the end, you will be integrating the subsystem. Okay. You'll be creating multiple modules, You will make sure that every module is working properly, and then if individually they are working properly, then you'll be integrating them. And finally, you'll be testing. That means you have to make sure that whether this individual modules and integrated modules are working properly in terms of some testing parameters to make sure whether the reliability of that particular product is met. Let me talk about more reliability. Then finally, the product has to be delivered. You would have to create a project documentation, and you would have to give a training to the end user. It's obvious. So if you develop a product and if you deliver it only, if you do not train the end user to use that particular software, that's not going to be done. So you have to train your people, you have to create a user documentation. Maybe you will be creating a video documentation. That one is a modernized version of making a documentation that is much more easier for you to do. And finally, you'll be maintaining the product. You'll be making an help desk, because at the end point, whenever you will be delivering a product, client may have endless number of queries. For the next 6-7 months, or for the lifetime of the software, you may be having an endless number of queries. Or the client may say that if you incorporate this particular feature, which is not present right now, if you incorporate this particular feature, then I think it will be better for us. Then you'd have to rework, you'd have to again start from the very beginning to reanalyze the requirement, to redesign, to recode, to retest, and to re-implement it with the existing version of the software. In that case, you'd say the version of the software may be changed. Maybe you delivered a version 1, and after integrating the newly developed requirement, you may be having a version K 1.1. Okay. So let us move on. I think we'll be discussing each and every phase individually, as because it is our plan to cover each and every phase, because this is our syllabus. We'll be covering each and everything. Let me talk about a very simple term. If you have got a paper and pencil, you can take a note on this. Believe me, this is going to be very important if you work for industry in future. The term is software metric. Metric is usually a term that is used to measure any unconventional thing that cannot be measured by using the conventional units. Like usually if you have to measure something, then we do use SI units or CGI units, but there are some things that cannot be measured by using the conventional units. Like if you have to measure somebody's emotion, will you be able to measure emotion in kg or centimeter or millimeter? You won't be able to do that. If you have to measure pain, so you cannot say I'm really having some pain and I'm having 15 kg pain. You cannot say that. So there are some things that cannot be measured by using the conventional units. Some unconventional things are up there that you'd have to measure. For that, metric is up there. In industry, if you have to suppose that I'm saying I really do believe ion. So how much I do believe ion, if I have to clarify this, there is no such parameter is up there using which I'll be able to clarify the reliability of ion. So in that case, rather I'll be using some different parameters in terms of marking the reliability. So these are matrices. In industry, there are several different things that are there. In software industry also, there are several different things that are there that cannot be measured by using the conventional units. They are to be measured by using some non-conventional parameters, and they are marked as metric. Like if you have to measure the reliability of a software, then probably you'll be using a metric. So software reliability uses different metrics to calculate the reliability. Whenever the turn will come, I'll just talk more about this. I hope it is clear. So let us move on to our next slide. There is a software characteristic, and this has got something to deal with the reliability. That's why I was introducing the term reliability intentionally. So this says that this particular graph says it is a bathtub curve. Okay, so as because it looks like a bathtub. So this curve is related to depicting the reliability of a product. How can you say that a product is reliable? Let me give you an example. Suppose that you have got a product A and you have got a product B. I hope I'm audible enough, because this is very important for you to understand. So you're about to measure the reliability of a product. You have got a product A and you have got a product B. Now, if you have to measure the reliability, then what exactly you will be doing? You will be giving 5 inputs to software A. or rather product A, you'll be giving these same inputs to product B. With respect to first 5 inputs, if the number of faulty output generated by the product A is 1, then the failure intensity of that product is 1 by 5, because with respect to every 5 input you are having a faulty output. And in case of the second one, with respect to same 5 inputs, mind it, same 5 inputs, if you get only 2 failures, then the failure intensity is going to be 2 by 5. So which one is better utilizable? Obviously the first one, is because with respect to 5 inputs you have got only one faulty output, but that is the strategy that you can use to measure the reliability. Okay, so this graph says that in the y-axis what you have is the failure intensity. Intensity means the rate of occurrence of failure. How many failures are occurring? If you have to measure the rate of occurrence of failure, rate should always be measured with respect to some parameter. Here the parameter that I have is time. Okay, so I would have to measure one thing that is called a failure intensity, and this failure intensity has to be measured in terms of time. Okay, so what I can say using that graph is, initially whenever you deliver a product, initially after delivery of the product, the failure intensity will be quite high. And as the time progresses, why this failure intensity is high is because you will be having lots of bugs, you'll be having lots of errors. And as the time progresses, the failure intensity is going to be deteriorating. Why it is so? As because you are about to fix the bugs, you are about to find out what is the reason behind, for the bugs. You'll be fixing them up. That's why the failure intensity is deteriorating. And in this particular phase, which is parallel to x-axis, you'll be having the most useful time, where a minimum or constant number of errors will be generated. So rather you can say a very minimum number of errors are generated. That's why it is fixed with respect to time. So at that point, if you have got only 5 errors, at that point also you may also have 5 errors. That means that is fixed. Or maybe at that point you have got 1 errors. At that point you'll also be having 1 errors. That means within this particular period of time, no significant errors are generated. But after this particular period of time, customer will generate a new requirement, new set of requirements are coming. At that point of time, you will again be having some newer number of errors, and the failure intensity is again going to increase unless you fix them up, unless you go for a newer version, unless you fix the new requirements. So that basically is a curve that defines the failure intensity, and that's because you can definitely say reliability of a particular software R is obviously inversely proportional to failure intensity. So the lesser failure intensity you have, the more reliability you will be having. That's obviously true. Clear? Any doubt up to this? Anyone? Do let me know if you have got any doubt. Okay, fine. Okay, so let us move on. Let's move on to the next slide. So I'll be talking about software process models. These are the things that are going to cover by me. Software process model, as I already mentioned during the discussion related to SDLC, that whenever you want to deliver any product, then you would have to follow some layered approaches. You would have to follow an approach based on which you can say these are the layers involved in development of my product. So in software industry, similar to that, SDLC supports basically different kinds of software process models, and these process models will lead to the production of well documented and maintainable software in the manner that is predictable. That is, there are so many different models are available. Each and every model is consisting of different phases. So you would have to choose your model before you start your development. And I'll be starting from the very beginning. I'll be starting from a scratch. I'll start with the most primitive model. Today I'll be discussing only one model. There is a waterfall model, and I'll be moving on. And the last model that I'll be discussing, not today, in the future course of action, when I'll be discussing the last model, a spiral one or an agile model. this is going to be the latest model. So I'll be starting from the scratch. I'll be starting from the most primitive model. These models do nothing but combining multiple phases of development that you must have to consider while you are about to develop a product. Okay, fine. So let us move on. Let us move on to the first model. The first model about which I will be talking is waterfall model. Waterfall model, the name is waterfall model is because it is a diagrammatic representation that resembles a cascade of waterfall. That means this model always follows this model. I'm sorry, this model always follows a top-down approach. You can say. I'm sorry. Yeah, a top-down approach. Top-down approach means this always moves on from top to down. So it is not that in case of SDLC also, it is not that you'll be picking up a random phase and you'll be starting your development. You would have to start from a scratch. You would have to start from the very beginning. There is a serial. You will not be in a position to break the serial. If you say that, sir, I'll be starting from construction. I'll be starting coding in future. Once I get the requirement, I would say it's not possible. So rather you would have to start from this particular phase. So these are the phases that are involved in waterfall model. The first one is communication, that is project initiation and requirement gathering, as it is already present in SDLC. In any SDLC, you ask your client to clarify the requirement. Once you get the requirement, you analyze it and you have a documentation. This is very important for you to understand. Each and every phase of waterfall model is definitely having an outcome. So if you complete that particular communication phase, if you get the requirements, if you analyze the requirements, then you'll be having a documentation. That particular document is called SRS. That is a software requirement specification document. Okay. So at the end of this communication phase, after your requirements are analyzed, you'll be having a jotted down requirements in a particular file, a noted down file, a hard coded file, coded by you in a particular language. There is a specific format for writing SRS. You'll be clarifying it, and you have to let your client know that these are the finalized set of requirements. I'm going to work against this. If you finalize this, I'm going to work against these particular requirements. After that, you'll be making an estimate. You'll be scheduling. You'll be tracking the percentage of development. You would have to have some milestone. You'll be having a project manager. The manager will be keeping track of how many staffs will be up there, who is going to work for what particular job, what is the schedule, when you have to complete what percentage of job. That is to be decided by the project manager, and that comes under planning. Then modeling, that is basically dealing with design. So you'd have to have this particular SRS, and you would have to design, you have to create some graphical notation based on which coders will be coding. So this is coding basically. You will be testing it also, as I already mentioned. Unless you test for your code, you will not be in a position to remove the bugs. And finally, deployment. You will be delivering the product. You will be asking them to revert back to you with any feedback if they require any kind of support. But this particular model, waterfall model, as I already said, that this model is following a top-down approach. And you'd have to aim at this particular deployment model. Just a minute. I had a call. Okay, fine. And you'd have to aim at this one. You'd have to aim at development. So the drawback, the major drawback, are listed in here. This model basically understand and reinforces the notion of define before design. So you'd have to define. What you have to define? You have to define the problem statement before you start real designing. Okay. And design before code. You have to have a design documentation before you want to start coding. That is true. That is true for every model. But this model expects to complete the entire requirement procedure before the next phase is going to be started. That means in this particular model, the basic thing is, if you want that you will be starting the planning phase, then you have to consider that the entire communication phase has been freezed. There is nothing left in the communication module. So you have done each and everything in the communication phase. So if you wish to backtrack, if you want that if you want that I'll be backtracking, I'll be moving to communication phase again while I'm working on planning, you cannot do that. It's because when you're working on a particular phase, it is considered that the previous phase has already been freezed, so you cannot backtrack. That is a major disadvantage. Why it is a disadvantage? Because while you are modeling for it, while you are creating a design, if the client generates a new requirement, then you would say it is not possible. That's because already the requirements that you clarified in here are freezed. So I will not be able to backtrack. So you would have to consider the design, you would have to consider the newly coming requirement after the development phase, sorry, the deployment phase is over. So once you deploy the first version of software, then only you can consider the requirement, and again you will be starting from the beginning. Okay, that is time consuming and unrealistic too. So freezing the requirement, freezing one phase before you are starting the job for the next phase is a constraint for waterfall model. You will not be able to backtrack. So let me talk about this. Let me show you what exactly are the drawbacks of waterfall model are. It is very difficult to define all the requirements at the beginning of a project. It's really true. Nobody can clarify the requirements at the very beginning. Let me give you a typical example. Suppose that if you ask me, let me give you one more example. Suppose that if my librarian, if Nokul sir want me to develop a library management software, then first of all, I'll be asking Nokul sir to clarify the requirements. As because Nokul sir is good enough at maintaining libraries, Nokul sir has a huge experience maintaining library, not only by using a software, but he maintained library by using the manual paper and pencil too. So how exactly a library works, he have a solid understanding of that. So as he has a solid understanding of that, it is quite easier for him to clarify me what the requirements are. But if a person who is not having any expertise of running a library, if you ask that person to clarify what the requirement is going to be for a library management system, that person will not be able to clarify most of the requirements in a single sitting. So you have to ask the person again and again to clarify the requirements. So if you have a solid expertise running an existing manual system, then it is pretty easier for you to clarify most of the requirements in a single sitting, as because you do have expertise running similar kind of system. You are manually running it. In most of the cases, in a single sitting, most of the clients or customer will not be in a position to clarify most of the requirements. So as because you will be simply stuck in a phase number one. So this model, the second one, this model is not suitable for accommodating any change. As I already mentioned, you will not be able to backtrack. Re-engineering is possible after all the first phases are over. That means you complete the first phases like this, you complete them once, you complete all the phases once, then only you will be able to backtrack. Okay. So practically this is tedious and time consuming. Working version of the system is not seen until late this project live. That means unless you complete all those phases, you will never see a prototype. The customer will never come to know how exactly the system will look alike, how exactly the system is going to function. As because unless all the phases are complete, you will never have a look at the system. It is time consuming. So at the end of development, whatever you are delivering, if the client is not satisfied enough with it, then you would have to again re-engineering the product. Even again, you would have to work on it. It will be time consuming. Fourth one, it does not scale up with the large project. That's because the large projects are to be divided into fewer number of modules. Each and every module may have enormous number of requirements that may come at any point of time. As because you cannot backtrack, so you will not be in a position to scale up with large projects. So this particular model is good enough at a project where the requirements are very small. Rather, this model is the most primitive one. None of the organizations in industry do use this model. I'm sorry. So real projects are rarely sequential. That means, that's because this diagram says it is a sequential approach. After you complete phase number one, then only you will be going to phase number two, then phase number three, and phase number four, and phase number five. It's basically a sequential approach. So this approach, this sequence or the serial cannot be, you cannot avoid this particular sequence. That's why in real life projects, obviously you will not be in a position to maintain a sequence like this. In an agile model, a modern one, you are free to do anything you like at any point of time. So if a new request comes after 80% development is over, you are bound to implement that. So in that particular model, you will not be in a position to do that. That's why it is considered to be a drawback. And this model, apart from this, what I can say is this model is documentation heavy. This model is having, at the end of the entire development is over, you'll be having huge number of documents for each and every phase, as I already mentioned. And one more thing, a realistic thing was, as because this model takes a huge amount of time for the first phase of development, for re-engineering, for everything, it takes a huge amount of time. So I would rather say, suppose that you started a project in early 2000, and if it takes around 5 years to complete, then the hardware version with which you started development of the project, maybe they will be obsolete at the time whenever you are delivering maybe the first or second phase. So that is the real life problem. The hardware version with which you started at the very early phase of development, maybe they are obsolete, they are not available in the market, as because it took a huge amount of time and these versions of hardware are not at all available in the market. This is one of the most important drawback you can say. Okay, so that is all for today. So if you have got any doubt, you can let me know. Any query, any clarification you need? Any query? Anything you want to ask? If you want to clarify your doubt, do let me know. Okay, fine. That is all for today. So I'll be sharing. I have already shared the presentation. I've already shared the presentation in the Google Classroom. I'll also be making a Google Drive folder. I'll be sharing all the presentation that I'll be delivering throughout the semester. Okay, so that's all for today. Thank you. Thank you so much.